7.3 Switches, Conductors, and Insulators. Let's say we built a circuit with 2 batteries and 2 light bulbs. And we want to connect them like this. Okay. The light bulbs are in a row. If we want the light bulb to turn on, we want to connect them. Now we have a closed circuit. It's closed because we can make a circle. We can see the electrons moving like this. It's a closed circle. Again, that's a closed circuit. Okay. However, if we disconnect this, now we have an open circuit. In an open circuit, the lights do not turn on. We can control a circuit using a switch. Here's a switch. Right now, the switch is open, but now it's closed. Open, closed. So a switch just controls whether we have a closed circuit with the lights on or an open circuit with the lights off. Okay. So in real life, switches look like this. But really, all it is just something like this. When it's connected, it's closed. When it's not connected, it's open. So if we built a circuit with a light bulb, 2 batteries, and a switch, if I were to draw it, it might look like this. 1 battery. Of course, both batteries must point in the same direction. 1 light bulb. And 1 switch. Before I use the symbol, before I use the symbol, let's draw the picture first. So it says picture right here. So here's a picture of a light bulb and a switch. Okay, we connect them. Okay, and really, in order for the switch to work, the wire must be connected over here. No, over here. That's actually okay. Now, to draw a circuit diagram, the batteries look like this. So here we have 2 batteries. This is the light bulb. The switch looks like this. Like this. So that's a switch. So when we connect them together, that's the circuit diagram. The symbol of the switch. So that's the switch. Okay. One more example. Here we have 1 battery, 2 light bulbs, and 1 switch. Now we just connect them together. That's our circuit diagram. Okay. Now, instead of the switch, I'm going to replace the switch now. Get rid of the switch. And I can replace it with different materials and see what happens. Let's do it in our simulation. So here's a switch. I'm going to get rid of the switch. Instead of the switch, let's try some other things. If I use a coin, is it going to work? Let's see. Yeah, coins work. So over here, the coin, does it work? Yes. What about a pencil? Let's try a pencil. Does a pencil work? Yeah, a pencil works. If you look on this side, Why? Because graphite actually also conducts electricity. Okay. However, if I were to use the pencil like this on the other ends, it's not going to work. Like if I use it like this and put this here, yeah, that's not going to work. But the graphite works. What about a dollar bill? Is paper going to work? Nope, paper doesn't work. What about an eraser? Nope. What about a paper clip? Sure, some of these work, some of these don't. So we saw that with an eraser. I'm going to use eraser. The eraser does not work. If you use a wood table, it's not going to work. Paper clip. Yeah, it's going to work. Some will work, some will not. In fact, if we were to do this, so we know that with a fork, it will turn on. Penny, it will turn on. The gold medal, it will turn on. Shoe will not. Diamond will not. Pencil is debatable. Some of them are like, if you put it at the two ends, it could. But this one probably won't work because you can connect here, but there's nothing over here to connect. So, in that case, some of these work, some of these don't. The ones that turn on, they're called conductors. The ones that do not turn on are called insulators. Okay. In general, conductors are metals. Insulators are other things. Most other things are insulators. Some conduct a little bit of electricity, some conduct almost no electricity. Okay. So why is a wire made of both metal and plastic? Well, the metal is used to conduct electricity because it is a conductor. It is a conductor. The plastic is an insulator, so it will not conduct electricity. And that's for protection. So we can touch the wire without getting shocked. Okay? And that's it.